In our lesson on the basic functions and on transformations, we learned that if we have an equation, y equals x, that the graph of that line, where x equals y, is all of the ordered pairs where the first number and the second number are the same, where x and y are the same, 0, 0, 1, 1, 2, 2, 3, 3, -1, -1, etc. And that gives us, if we go over 1, up 1, 1, 1, 0, 0, -1, -1, and we know that the graph of that is a straight line. If we had an equation, for instance, that was y equals 3x plus 2. We know that this is going to look similar to the line y equals x because we just have a plain x here. X is to the first power, y is to the first power. So we're going to have a straight line of some kind. So we know immediately that this is linear. If we use what we know about transformations to graph this, this 3 means that we are going to stretch by a factor of 3. And the plus 2 means that we're going to move up 2 units. So if I stretch by a factor of 3, that means that when I came over here to 1, instead of just going up to 1, I'm now going to go up to 3. So over 1, up 3. And the same thing here, back 1 and down 3. So if I multiply x by 3, that gives me a stretch, and I'm going to do this with a dashed line because this is not my finished line here. I'm going to have something that looks like that. The up 2 means I take this blue dashed line and I move it up 2 units. So 0, 0 moves up here to 2, and then I'm still going over 1 and up 3, and back 1 and down 3. So this line, through those 3 ordered pairs, is my line y equals 3x plus 2. Now, normally we do not graph equations of lines using transformations. Transformations definitely works, but because we use linear equations so often, we've come up with names for each of the separate parts. So, notice in this equation here, this number, the 3, is how much I go over and up. It's my rate of change. It's called my slope. And notice that this number is where I went from 0, 0 straight up the y-axis to this point. So that point is where the equation of the line crosses the y-axis. That's called the y-intercept. And we're going to see that the 2 is the y-coordinate of the y-intercept, because the y-intercept is an ordered pair. It's a point. And because it's straight on the y-axis, that means x is 0 and y is 2. And we're going to see that that always works. The number that's being multiplied by the x is the slope, the rate of change. It tells us how steep the line is. The number here is always going to be the y-coordinate of the y-intercept. So we can write a formula for that. We can say that if we have an equation, y equals mx plus b, we know that's always going to be a linear equation. The graph will be a line because x is to the first power and y is to the first power. We know that m, the number being multiplied by the x, is the slope, the steepness or rate of change. And we know that the b is the y-coordinate of the y-intercept. So this form is called the slope-intercept form of a line. The slope-intercept form of a line. So if I'm given an equation of a line in slope-intercept form, for instance, y equals 2/3 x plus 5. I can immediately identify the slope and the y-intercept. I'd like you to do that. I'd like you to pause the video, write the slope, and write the y-intercept. And remember that the y-intercept is an ordered pair, so write it as an ordered pair. Parenthesis, number, comma, number, parenthesis. Pause the video, do that, and then check back. All right, so we see that our slope is m equals 2/3. And my y-intercept is the 0.05. And we can use that information because this is in slope-intercept form. We can use this information to easily graph the equation of that line. So what we're going to do here is we're going to graph using the slope and the y-intercept. So the 2 here, let me rewrite this way. The 2 is how much we're going up and down. The 3 is how much we're going over. That's also known as rise over run. So that's the way a lot of students remember slope is rise over run, change in y over change in x. So we can plot the 0.05 and drop that point. And then we can go up 2 units in the y direction. And then over 3 units in the x direction. And that gives us another point, another ordered pair. And as soon as I have 2 ordered pairs, I have enough information to graph any line. All I need is 2 points to draw the line. And I can see that this ordered pair, this one was 0,5, my y-intercept. And this one, if I went up 2, that's changing the 5 to a 7. And over 3, that's changing the 0 to a 3. And I have the ordered pair 3, 7. And then I can just draw my straight line straight through those 2 points. And I have graphed the line using the slope and the y-intercept. If the equation is given in the form y equals mx plus b, using the slope and the y-intercept is a good way to graph it. But there's a lot of other ways to graph lines. If I have an equation in this form, let's say 3x plus 2y equals 6. This is what's called standard form. In standard form, you have a times x plus b times y equals c. And notice that the x and the y are both to the first power, so that does mean that this is still a linear equation. So this is still linear because the x and the y are both to the first power. I can graph any line by just finding any 2 points that are on the line. Because remember, the equation of the line, if I look back at this one, any ordered pair that I had on this line, let's say I had the point right here, or point right here, or point right here, or here. This is infinitely many different points. And any point on that line, if I take that x and that y and plug them into the equation, I would get a true statement. That's what it means to be a point on the line. So for instance, I had the point 37. That would tell me that what I'm trying to see is if 7 times 2/3 times 3 plus 5 is a true statement. So I can cancel my 3 and I get 2 plus 5 and 7 equals 7. So the point 37 is a point on this line because if I plug 3 and 7 in for x and y, I get a true statement. So if I want to graph any equation of a line, all I have to do is find 2 points that make this a true statement. 2 values of x and y, but if I plug them in, I get a true statement. And 2 points that are going to be easy to find when it's in this form are going to be the x and y intercepts. The x and y intercepts. And remember we talked about the y-intercept on this previous graph was where the equation of the line crossed, the graph of the line crossed the y-axis. So the y-intercept is the point, the ordered pair, where the line crosses the y-axis. And because it's on the y-axis, x is not going left or right at all. We know that's always going to be a point 0, something. If we have the x-intercept, is the point where the line crosses the x-axis. So if it's on the x-axis, that means it's not going up or down at all. That point, the y has not changed from 0. So you're always going to have an ordered pair of some x, but my y will always be 0. So to use the x and the y-intercept, to find the x and the y-intercept to graph this equation, 3x plus 2y equals 6, what we're going to do is to find the y-intercept. We know that x has to be 0. So we're going to let x equal 0 and find y. You go ahead and do that. Go ahead and literally substitute 0 in for x and then solve for y. And then write your answer as an ordered pair. Parenthesis, number, comma, number, parenthesis. You go ahead and pause the video and do that work. So if we solve this equation, 3 times 0 is 0. We have 2y equals 6, y equals 3. So my ordered pair, remember we let x be 0. So my ordered pair is 0, my y is 3, so I have the point 0, 3. To find the x-intercept, that is where the line crosses the x-axis. We know that y is equal to 0. You see here? Y is equal to 0 always. It's for an x-intercept. So we need to find the number that if I let y equal 0 makes the equation a true statement. So we're going to let y equal 0 back in our original equation. Way up here. We are going to substitute in a 0 for y and solve for x, and then write the ordered pair. You pause the video and do that work yourself. All right, so we see that what we're trying to do is find the value of x that if y is equal to 0, I have a true equation. 2 times 0 is 0, so I have 3x equals 6. So x equals 2. So I have the ordered pair 2, 0. Now I have 2 points. I happen to have these 2 special points, but all I need are any 2 points to graph the equation of the line. So I can plot those 2 points. To 0 and 0, 3, and I can draw my line. And that is the equation of this line. Excuse me, the graph of the equation of the line 3x plus 2y equals 6. Now it's important to remember we've learned 2 different methods of drawing a graph of a line. We've learned the slope-intercept method when it was written in slope-intercept form, and we've learned the plotting the x and the y-intercept method when it was in standard form and it was easy to divide and get the x and the y-intercept, the coordinates for those. But sometimes your x and your y-intercepts are not nice integers. They could be fractions, and that could be more difficult to graph. So let's say that I have an equation that looks like this. Two x plus 5y equals 11. If I tried to find my x and y intercepts, I'd end up with fractions, 11 halves and 11 fifths, and those would be difficult to graph. So what I need to do here is try to find numbers, x and y, that if I plug them in for x and y, it would give me that x and y are nice integer answers. And this is going to require playing around a little bit. So let's say that I let x equal 3. Then I have 2 times 3 plus 5 times y equals 11. So what I was thinking here was 6 plus 5 times what equals 11. And if I solve this, I get 5y equals 5 and y equals 1. So I have nice integer answers. So the point 3, 1 is a point on my line. Let's try another one. Let's say that I want to put in y equals 2. If y equals 2, when I subtract, I get 2x equals 11 minus 10 is 1, x equals 1/2. And that's going to be easier to graph than 11/5, but it's still not an integer. So what if I say, all right, well, let's let y equal 3. So I have 2x plus 5 times 3 equals 11. So 2x, 5 times 3 is 15. So when I subtract, I get -4. So x equals -2. And now I have integers. So this takes a little bit more work of kind of playing around with the numbers, figuring out an x or a y, that when I do the math, I end up with an integer. But I have found 2 integer points on the line. Just any 2 random points, but as long as they make the equation a true statement. Notice that if I do 2 times -2 plus 5 times 3, I get -4 plus 15, 11 equals 11. That makes it a true statement. 2 times 3 plus 5 times 1 equals 11. 6 plus 5 equals 11. 11 equals 11. That's a true statement. So that tells me that these 2 points are on my line. So I have -2, 3, and I have 3, 1. And then I can graph. And it looks kind of like it's going right here through the point 0, 2, but it's not. That is not right at 0, 2. It's a little bit off of 0, 2. And then notice this point here, 1/2, 2. I didn't graph that one, but that is my point right here, 1/2, 2, right on the line. So that's a third way of graphing a line, just using any 2 ordered pairs that make the equation a true statement. In our next video, we're going to look at the concept of slope in more detail. The concept of slope of a line is a very, very important concept. So we're going to revisit this form of the line and talk a lot more about what does slope mean, how can we find slope, and then how can we use it to